All right, let's take a look at some things and some problems involving proportions. Again, hopefully this is review for you. Hopefully you can think back to what you probably learned back in like middle school or earlier in high school about proportions, and this can be kind of review for you. But just in case, let's go over a few things. Remember in our last video we talked about that a proportion is where we take two ratios and we stick an equal sign in between them. So we take like A equals or A over B and C over D and we put an equal sign between them. That makes it a proportion. We're saying that these two ratios are equal. In a proportion like this, A over B equals C over D, A is called your first term, B is your second term, C is your third term, and D is your fourth term. When I have them kind of ordered in that fashion, the first and last terms, or in this case the first and fourth terms, they are each called an extreme of my proportion. An extreme of my proportion. That's an extreme, and this guy right here is an extreme. The middle two terms, the second term and the third term, they are each called a mean of my proportion. So B is a mean and C is a mean. Now, why do you need to know that? Well, I guess you don't really need to know that. But the next thing we're going to learn, which is something that's very valuable to us, is technically called the means extremes property. So I wanted to kind of explain where that name comes from. You actually probably know this by a different name. What the means extremes property says is if you have this proportion A over B equals C over D, then I can take that proportion and I can kind of rearrange it a little bit. I can take the A and the D and I can multiply them together. And then I can take the B and the C and I can multiply them together. So you can see what I did is I took the product, this right here is the product of the extremes. This right here is the product of the means, and those products are equal to each other. Now this should look familiar to you. You probably refer to this as cross multiplying, right? Cross multiplying. Or somebody at one point might have described it to you as the cross product of the proportion. It's the same thing. Technically it's called the means extremes property, but you might know it by these names, cross multiplying or taking the cross product. So let's look at a couple examples of what we can do with this. In this figure here, we have a relationship where two ratios are equal to each other. We have a proportion. AD over DB, let's do some color coding here. AD over DB, AD over DB is equal to CE over EB. Sometimes it's helpful to kind of color code those so you can kind of see what parts are being compared to what. So in that picture we have that proportion, and now we have CE is equal to 2, EB is equal to 6, AD is 3, and what's DB going to be? So we'll just replace these names in this proportion with these measurements. So AD is 3 over DB, which we don't know, so I'll put an X there, equals CE, which is 2, over EB, which is 6. Now there's a variety of ways you could solve a proportion like this. In fact, some of you might kind of see what the answer is going to turn out to be. You can just kind of visualize based on what this ratio says and what this ratio looks like. You can kind of visualize what x is going to be for some of you. But if not, what we can do is we can stick with our trusty old means extremes property, our cross multiplication, and we can take 3 times 6 and say it equals 2 times x. Or in other words, that 18 is 2 times x. Divide both sides by 2, and we get a value of 9 for x. So dB is equal to 9. And again, some of you might have been able to kind of see that, all right, if I have 2 over 6, the bottom number is 3 times as big as the top number. So if I have a 3 right here in my numerator, then that right there must be a 9. Again, you might be able to see that in your head. If not, you just go to the cross multiplication to try and figure it out. Now in part B here, we got some new values for some of these measurements. So let me get rid of these old ones. And let's stick in these new ones. AB is equal to 10. Oh, AB, that's this whole side here. That's the red plus the orange. So I'm going to kind of write that like this. This whole thing is 10 right there. And DB is 8. CB, so that's this whole side, is 7.5. And I need to know what EB is, so I'll put an X right there. Okay, so if I go to set up my proportion now, the problem is I'm missing some things, right? I don't have AD. It didn't straight up give it to me. But I can kind of think a little bit here, and I can use the segment addition property and realize that if this whole thing is 10, and this part of it is 8, then this part must be 2, right? Because 2 plus 8 is what's going to give me the 10. So I have AD is 2 over DB, which is 8. Now on the other ratio, I have CE and EB. I don't have either one of those. I have EB as an X, so I'll go ahead and put that down right there. But what am I going to use for CE? I can't stick a Y in there, right? Because if I put a Y right there and just use another variable, then I'd have two variables in my equation, and I'm not going to be able to solve that. So I got to think, okay, if this whole segment, CB, is 7.5, and this part of it is X, then I can represent this part as the whole segment minus the X, minus this part of it. So I can write it as 7.5 minus X. And now I have a proportion that I can solve using the cross product. So, you know, this one you probably need cross multiplication to solve. I don't know if you'll be able to just kind of visualize what this ratio turns out to be with these x's in both these spots. So let's go ahead and cross multiply. We'll take 2 times x and say it equals 8 times the product, or sorry, times the quantity of 7.5 minus x. Now I need to distribute this 8 in, so I'll have 2x equals 8 times 7.5, which is 60, minus 8x. I'm going to add 8x to both sides, so I have 10x equals 60, and that means that x must equal 6. So x, which is EB, that equals 6.